Okay. We ready? Almost ready? He's like a lot better. Yeah.
Is an A was multiplied by 1 minus or to the M over 1 minus everyone. It's not a plus or a minus. Or A was nice. I don't know which one. It's not. Yeah, I know 1 minus R on the bottom, and then I know 1 and then R at the end.
So that's.
Yeah, minus R. Okay, yeah. Perfect.
Yeah, sure. So. Okay, 10 seconds. Here we go. Oh. Okay, everybody, let's do number 1, shall we? Let's see who's gonna help me with the first one. Okay, it's everybody. Great. Okay, wait. Go ahead and just in the whiteboard in front of you. Would you please just draw a sketch of that number 1? Just draw a sketch of it. That whiteboard in front of you. So it is going down. How far down is it going? To 0, right? And of course, the points that if you're doing like a really good graph of it, not just a warm up, the points I'd be looking for are 0, 1, and then 1, 1/3. But I'm not even looking for that kind of detail. I'm just looking for this quick sketch. For 2, would you please show me what that one looks like? This one is going up, of course. So it still goes to that same point and it goes up kind of slowly, but it does go up, doesn't it? I'm gonna make it so it makes sense. Let's go up this way. Okay, and number 3, would you show me what that one looks like? Okay, so I'm seeing lots of people conducting orchestras here. That's great. or something like this. How low does this one go? It approaches zero, doesn't it? Are we sure it approaches zero? Or make, because 0.97 is pretty big. Are you sure it approaches zero? Eventually, doesn't it? Yeah, that's just a property of exponential functions. It's either going to grow forever or decay to pretty close to zero, such that the limit is zero. Does it ever actually get to zero? So summarizing 1 and 3, it doesn't make sense that repeated multiplication of anything between 0 and 1 leads to a very small number. I'll say that again. Repeated multiplication of anything between 0 and 1 leads to a very, 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 very small number, no matter what that number is. Any number between 0 and 1. Okay. Number 4, for arithmetic, Christine, what was the formula that we had? Do you remember? And over 2. I don't know, I put that at the top there. That's really nice. Thank you so much. Eileen, geometric. Correct. Line. As we proceed with this unit, how much longer is this unit? The test is 2 weeks from yesterday. Just so you know, 2 weeks from yesterday. So yes, there's a 15 plus 14. Is that right? 29? I think, yes. Yes, there's one more unit after this. So this is not the end of the party. Let's move to the packet, shall we? So far, we've been studying geometric sequences. My understanding is that a geometric series is the sum of an infinite geometric sequence. Some people say that if you just add up some of the terms, it's a series. But from what I'm seeing and how we're going to be presenting in this class, if I'm talking about a geometric series, it means we're adding up an infinite number of terms. I'm going to take a step back for a minute and just go to the warm-up really quickly, just to introduce this. Is it possible to add up an infinite number of terms and to get like an actual number? Well, let's see. If we add up the numbers 1/2 plus 1/4 plus 1/8 plus 1/16. I want you to think about this. Do we need a common denominator here? It's very difficult since there's how many terms? Infinitely many terms. It'd be very difficult to get a common denominator, but discuss with your partner. What do you think this would add up to, if anything?
I remember what.
They will get an answer? Yeah, Kimmy, what do you think? Do we agree with that? It approaches 1? How do you know this? It just seems right. Nice. Yeah, if we go back to maybe an elementary school version of fractions, did you talk about like representing 1/2 kind of like this, like a pizza or something like that? So there's a 1/2. And if I'm going to add a quarter, then I could take that empty space and cut it in half. So here it is. This is 1/2 plus 1/4 is 3/4. You may remember seeing that exact situation. Do you remember from your study of fractions? And of course, I'm going to add a 1/8 now. That's just going to take that empty part and add that, cut it in half. And then plus 1/16, I'll take the empty part, cut it in half. So you can see that pretty quickly that if I were to sum all of these together, infinitely many, it would approach the number 1. And we would say that it equals 1. If it's approaching a particular number, we would say that it converges to 1, and therefore it equals 1. That's the idea we're going to be talking about. So we are going to be adding an infinite number of terms. And sometimes it's possible, and sometimes it isn't possible. So let's take a look and see the rest of the story. So here we have geometric theory. Does this one make sense? The left side is very general. It's just saying that there's infinite number of terms. On the right side is specifying that each term is the first term times a common ratio like we talked about. That's geometric. That's a geometric series. Notice the top is infinity. If the top is blank, the implication is that it's going to infinity, unless there's just a mistake. Let's see, definition. Let A sub n be a geometric sequence with the first term A sub 1 and a common ratio R. Recall that this is the sum of the first n terms. So let's explore what happens to infinite series S if R is between -1 and 1. Okay, so well, R is between -1 and 1. That means we have S, and I'm going to call this S sub infinity. 1 minus R to the infinity over 1 minus R. Remember in the warm-up we talked about, if that R is between 0 and 1, and it's repeated by itself, or multiplied by itself a repeated number of times, that this term would approach 0. But how about if you multiply negative numbers between things? Like negative 3/4 times itself. Is that also going to approach 0? Negative 3/4, negative 3/4, negative 3/4. I think it's going to bounce back and forth in the positive and negative, but the values, the absolute values, will get smaller and smaller until they effectively become 0. So if R is between -1 and 1, what we have is a beautiful equation. Do you see what's going to happen to the top if that R to the infinity is 0? We just have A1 over 1 minus R. Very, very elegant. Now, if R equals 1, what that means is that we have A1 plus A1 plus, wouldn't this be R equals 1? The terms stay exactly the same. Is this ever going to add up to anything? Like, is it going to like approach a single number like it did with that earlier problem? No. So what we would say here is divergent. The sum diverges. It doesn't approach any particular number. And if R is greater than 1, that means if we have A sub 1, then A sub 2 will be bigger than A sub 1. Does that make sense? Since R is greater than 1. Then A sub 3, what do you know about that? It'd be bigger than A sub 2, wouldn't it? It's bigger than A sub 2. And I hope it makes sense that if we're adding up numbers that are getting bigger and bigger and bigger, is that going to converge to any particular number? It's not going to converge, it's going to diverge. So this is divergent. So we would say it convergent here, just to be complete. It converges exactly to that number on the right. Okay, let's move on. So we have a theorem. If S is a geometric sequence, a series, then it converges to a sub 1 over 1 minus R. And this is just another way of saying that R is between -1 and 1. And the geometric series diverges if the absolute value of R is greater than or equal to 1. We already said that in the upper portion. So this is just a summary of what we did above. Yeah. Let's try this. Example 4, determine if each of the following geometric series converges or diverges. If it converges, find its sum. So all we have to know is it geometric? And then if it is geometric, is the ratio between -1 and 1. So does number A, example 4A qualify? Yeah. What is R here? 2/3. If you're ever not sure, you could just take one term and divide it by the previous term to get that ratio. And yes, that does give us 2/3. Okay, so I know that the S, and if it's blank, if it's just capital S like that, the implication is it's an infinite sum or a geometric series. The first term is 2 over 1 minus 2/3. To solve this, or to simplify this, I'm just gonna multiply the top and bottom by, would be a nice trick. Multiply top and bottom by 3. Does that make sense? I know you could do 1 minus 2/3. I'm just giving you an escape route for when it gets more challenging. If I multiply top and bottom by 3, top is 6, the bottom is 3 minus 2, giving us 6. Any questions? Okay. Let's see if we could do B, C, and D. And I believe in you. With the neighbor, as you finish each one, make sure they got the same the B, C, and the D. I'll be calling on 3 people, of course. Okay, ready or not? I want to hear about it. Sophia C, can you help us with B? How do you know this? Okay, is there no R? I think you're right that there's something going on there. But I think there might be an R. You can see? Exactly, yeah. There is an R. But I think that what you saw is that the numbers are growing. So what's the point of trying to add them all together? So I think that at an intuitive level, you're exactly right. So thank you. But I do want to recognize that it is geometric since that's well, I guess don't even ask. I guess. Yeah, you're good. Geometric, but it is divergent. but divergent. How would you find the R if that were a question? Yeah, Levi? Are we okay with that? Does that make sense? Or you said 16 divided by 12? Or 64 thirds. Instead of dividing by 12, let's multiply by 112. I think that's probably the worst pair to use. But you'll notice that both of these, the first two, simplify to the same thing. All three simplify the same thing. So yes, it is geometric. It is divergent though. And you can see if the numbers are growing, it has no chance of converging. Thank you, Sophia. Never late Lydia. Oh, okay. Well, let's do it together. Can you remind me of the formula for this? Let's see. We're looking for the sum. Right, that's what the sigma is. The sum of how many terms? Yeah. Are we good with this? Is that what you were gonna say and I stopped you?
Oh, yeah, oh, I thought you were just like asking for a good them with it. I was just gonna say, that you put the
Um, okay, so overthought it a little bit. But that's okay. It happened. And then working this out. Is it 12? Okay. Cool. Now, are we sure this is geometric? How do you know? There's a repeated ratio, a common ratio of that 1/3. And we know the first term is plug in that one. We get the first term. Thank you, Lydia. And finalmente, D. Zach, can you help me out with this one, please?
Yeah. I think, 4 over 1.
Okay.
Yeah.
Do we agree? Any questions? Thank you, Zach. And we've spoken about this earlier in the year, the fact that 0.9 bar is not less than 1. It is exactly equal to 1. Is that a comfortable idea for you? A little bit uncomfortable for some of you? More proof that it's true. Show that they're equal by viewing 0.9 bar as a geometric series. How can I show that? How is that a geometric series? Yeah, Levi. Wait a minute. Let's let this sink in. Is this true? Plus, etc. I'll give you a moment. Is it geometric? Cool. If it's infinite geometric, you know how to find the sum. I'll give you a moment. Did you get it? That the first term is 0.9. The common ratio is 0.1 or 1/10. And I think 1 minus 0.01 is 0.9. Look at that. Looks pretty. It's exactly equal to 1, as long as you're adding up an infinite number. More proof that it is true. Applications. Okay, let's try the financial one first. Jim Bob. Parents couldn't decide on a name, apparently. Invest $400 per month into a mutual fund. If the per annum rate of return of the mutual fund is assumed to be 8% compounded monthly, how much will Jim Bob have after 30 years, 360 deposits? Okay. What's gonna happen in his first payment? It starts at 400. And then it gets some interest, doesn't it? 1 plus. Is this looking familiar? 1.08 over 12. And the first one, the first payment is gonna get 359. The second one, 400, 0.08 over 12 to the 358. It's going to be in there 1 month less, right? This is the second payment. Third one, I think you see the point. This goes up to the 360th. 360th payment will be 400. It doesn't get any interest. That last month doesn't get any interest. So if we're adding all of these up, I want you to take a moment to think, what would they add to? Make sure your friend, your neighbor slash friend is on the right track. After you have a direction here. Is this a series or is this the sum of a sequence? Yeah, a series would be divergent, right? If they get infinite money. Okay, so this is equal to, who can help me with this one? Yes, we have. Yeah. 300 what? Good question. Is it 59? 50. Over. That's a nice simplification down at the bottom, isn't it? Okay, so any questions? Uh, with any calculator, but let's make sure this is right. Yeah, Levi? Yeah, how do you know that that's R? Yeah.
I feel like you reverse the order of adding, because you not go out, you don't want to do it for instance. But this is different, like this, 100%. Right, 100%.
Yeah.
But, yeah, I was thinking about how are these payments growing? You get a little bit of interest every time, so it's one more fee. Which is right, it's greater than one, hopefully, that's how the money's growing. If this one has 8 of them, then we multiply by another one, and we'll have 50 another one. That's the common. So that, I think I put that on 130.
Should be 360. It should be 360. Yeah, this is a sum of 360 payments. I think it goes here, doesn't it? I think that's where it is. Yes. Last time, because this is an infinite. Right, the interest is more than one, so, and if it were infinite, there'd be a crazy amount of money. One minus r to the n over one minus r. Oh, and this should be. Oh, did I mess up? Oh, yeah, I think I need to move some things, don't I? I see. Okay. Yeah, this should be 1 minus 1 plus 0.08 plus to the 360. Oh, I see. So you.
We made this. This is it. First then, I think this is, because when I multiply the table, we have to be 1 over. Because the 400, then each time we multiply by, that goes back to 1 minus r t and the 360 then.
Pardon?
Yeah, well, because, and if you look at the first one, that's the biggest. It's the biggest amount. So generally, when we're talking about these two, like the 2 points, you start with the smallest. And this is growing by that time.
So that's where you put in your computer calculator. How much does that give this person? Maybe you make exact. Yes. Well, we're using S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. This is not infinite. We have to go back to that. And maybe this example should have been in the previous day. That would have made more sense. It's a little misleading this way. Did anyone get a value? Was it like $500? It's gonna grow, I know. Maybe more than 500. Yeah, Levi, you got it? Woo! Anyone else get that? Yeah. 596,000, you said? Point down to the penny. From $400. Not too bad. Good luck finding a mutual fund that will pay 8% per year, but there's some really good ones out there. Any questions? Perhaps your question is, can we try another? In that case, the answer is yes. Have any of you ever dropped a ball? Yes? Oh, yeah. You're always welcome to do that. I'd be interested in hearing. Did you do like 1 over that factor? Oh, okay. Okay, so you got one over our growth rate, and that works, that does work. So we reversed it. And it's, since it's the same numbers, it's gonna work either way. So any of you who've dropped a ball know that after you drop it, it bounces. Yeah, so here we go. A ball is dropped from a height of 2 meters. Each time the ball bounces, it reaches 75% of its previous height. How far will the ball travel in total? So we're talking about vertical height, vertical distance. I'll give you a moment to talk about this, maybe to sketch it out a little bit. It's a little tricky, so be careful. How many times is this ball bouncing? Infinitely many. Yeah. Does it? I guess one is like laboratory versus reality.
Got it.
Yeah, so the down end of the motion.
Okay, one more.
Yeah, so, I mean, 7.5% is really.
No, no, like, it went down a lot, that five, down, up to one.
Yeah, points of
No, but it went down, but it came up a lot of point five, and then it went down, right, and then, whatever. So, yeah.
Did you get it? Okay, let's talk us through this one. Someone hasn't given us an answer today yet. This one. Yes, I mean,
I just wrote out the phone numbers and I was at it, so I was like, between 2.5, 1.5, like 1.5 again. 1.125, like 1.125, then I forget, I'm kind of other things that happen. So it was like, disregarding the food, is, I guess I just started at 1.5, and then I did recording to that to 1.5, so we did, 1 line, 0.5. To get that, and then I was like, do, have it.
1 minus what? Okay. 2.75, okay. And from there you got. Okay,
Times 2.
and you're saying all that together is equal to 14, what do we think? 14 meters. Okay. I hope that that makes sense. Okay, Kimmy, do you want to share with us what you did? Okay, I'm sorry, so two, say it one more time? Oh, you did two and then did put that over? Oh. So. Okay. So you did this. Okay. Put this over 0.25, what do you mean?
Is that when you
Oh.
add 2 and 1.5.
Oh, okay.
You can bring that to 1. Yeah. You can handle it.
Oh, so you can give me term by term, I'm just confused about. Case of one, okay. Plus 1 point, I'm sorry, for some reason, 1.5. That's a sub 1? Why is that one term? I'm just curious. Okay, so. I see, so like this and this, okay, so there is our 0.15, 2 plus 1.5, interesting. So then the second one would be, this is what you're saying, which is 75% of that. I've never seen that before, that's interesting. Nice, I'm a little afraid of it. But okay, yeah. No, I think that's good, since it's a length, yeah, we can still take the same percents. So that was your A1, and then you put that over 1 minus 0.75. And it worked out to be 14. Okay. Interesting. Yeah, I was thinking something else. So like I was thinking this and you were saying this. I had a hard time merging the two. So thank you for sharing that. That's really nice. Anything else? Any other way? Yes, please. Okay.
Over, 1.5. That's the thing, is that, and then, I started that 1.5.
So this is like 80 and this is 6, something like that. Okay. Good. Any other ways? Yeah, Levi?
Thank you. I think it's fine. We divided by 75. I was thinking of it, anybody who's down there, I guess,
Okay, so -2 equals. What do you think about that? No? I think these all great ways. And the more I think about yours, the more I like it. I think it's really innovative. Do that as a single motion. Right now it is 2:31. We'll resume at 2:34 and finish this up. Okay. Let's finish this up. So today we're gonna learn how to count. And I think you already know, first of all, how to count basically, but let's take a look at this first example. Suppose Frodo has 3 shirts and 5 pairs of pants. How many different outfits can they create? We're just checking to see with the neighbor if they have any idea how many outfits they could create. Yeah, I heard the answer everywhere. 15. How do you know this? 5 times 3. Why is that? Why is that true? It's called the multiplication principle. Have you seen a tree for these? Sometimes this is made by trees, like you start from nothing, you make the first choice, you can have shirt 1, shirt 2, or shirt 3. And then from here, each one of these could have 5, 3, 4, 5. So we pants 1, pants 1, pants 2, pants 3, pants 4, pants 5. Is that right? And then I'm gonna skip that middle one because I have little room. Pants 1, pants 2, and this just is a way of illustrating all the different combinations. Like if I'm right here, that means this Frodo has chosen shirt 3 with pants 2. Right? If I'm over here, that's a different thing. If I'm right there, that means he's chosen shirt 1 and pants 4. So, and you can see very clearly at the bottom, there's going to be 15 if I were to fill them all in. That's the multiplication principle. So 15 different outfits. Airports all have 3-letter abbreviations like LAX. Well, our airport is LAX. Toronto is YYZ, so they can repeat. So how many codes are possible? Well, yeah. Did I do something wrong? Well, I don't know. Good question. Yeah, and X means international, I believe. I don't know. Oh, did I start with mine? Okay, interesting. Thank you. It's part of that system. And then maybe it's international, outside of America. I have no idea. That's a good question. Why? So the question is, how many codes are possible? So we're gonna say the no restrictions, like we're gonna not say that Canada has Canada, yeah, has all like such and such. So it just means the first letter could be any one of 26, the second one 26, 26. And how many codes are possible? 26. 5,000 and what? 76? Okay, thank you. Cool. That many different combinations. Or that many different codes. And one last one. I think this one's really interesting. I'll give you a moment. This one's difficult to put together, but read it, discuss.
You have option 5. Okay, you guys are right. I'm saying.
Oh, yeah.
I think.
Yeah, exactly. Okay, so obviously for bread, I'm just gonna fill that in with 6. For cheese, I can fill that in with 4. But after this, I'm not gonna do times 5 because if I do times 5, the implication is you can only have one. Just like Frodo could only wear one pair of pants, practically speaking. So it's not like you could just choose one. So what am I gonna do here? Hey, Christina, you have an idea? Oh. Does that make sense? Topping 1, you have a choice. Yes or no? Topping 2? Yes, no. Nice, Christine. One, 2, 3, 4, 5, 6, 7, 8. I say 2 to the 8th times 3. 2 to the 8th is 256 times 3. 700. 768. Yeah, that's your choice. Yes or no. Yeah, so you can get all of them, or you can get none of them, or you can get one of them, or 2. That allows for all of the different possibilities for the topic. Interesting twist, huh?
Yes or no.
Exactly. And technically for bread, you could also say no, so that would be 7, wouldn't it? Like you could just have a cheese and onion sandwich with no bread. Okay, so maybe okay, you're right, that makes more sense.
Yeah.
Otherwise, your figures, it's just not gonna work out well. But yeah, practically speaking, this is what we're looking at. So that's what I got for you for today. You have a little bit of time to work on the assignment. Oh, one thing I forgot to mention. Test corrections due next week. Thank you. If you have them, yes, go ahead and turn them in. How many of you are thinking about taking the AP exam or have signed up for the AP exam for this class? Yeah, a few of you. I just want to give you some advice. One moment. Here it is. Oh, thank you. Just right there. Over, please. Okay. So, last year after AP exams, I thought about it a little bit too late, but I really wanted to see the students' experience with AP exams. So I took a survey of my kids. I had like 50 students in the class, but it was in summer, so only 11 replied, so keep that in mind. So how much extra time do people spend studying? So you can see it ran the gamut. Oh, it's frozen. Thank you. I'm sorry. Thank you. It's all over the place. That 9.1 is kind of interesting. Not including test day, how stressed were you about the exam? So, so yeah, 5 I think was super stressed out. So no one was super stressed out, which is good. Did you enjoy taking it? Are you pleased with your results? They're nice, right? Do you think you made the right decision? The 9.1. Right, that 1 out of 11. Would you recommend taking it? It's probably the same person. They're just bitter. Something happened. But they were satisfied with the results. So it's a little bit mixed signals. Okay, so to help AP classroom videos to see what material, YouTube videos there. I guess there are 4 YouTube videos for this. Old notes and AP Central. Polar coordinates were barely on there. Angle formula is not really necessary. Lots of functions and graphing. Oh, that's a good question. All these are pretty, maybe they didn't even fill that out. I don't think there are 11 comments. 1, 2, 3, 4. There's only nothing. We've covered everything. We've covered everything a long time ago. It's not on it. Yeah. Yeah, I think that actually I don't think it is. I don't think it is. Logs and exponential. Okay, so advice. AP test is not nearly as difficult as the class. Yes. Watch the videos. See, study major concepts like trig, graphing functions. No need to go into little things. Yeah, I'd love that. Don't study. I promise you're bound to excel. Yeah. Yeah, this is all anonymous, of course. I don't put too much pressure on yourself. So how could I have helped? Thank you. Yeah, look over my notes. Now that's how do you feel about the exam? Let's see. That's the one.
Why did they? Oh, no, they didn't rate it on a scale. There's no numbers.
I-
Some of the last one was exactly right.
Okay. Anyway, just so you know, the big thing is I don't want you to stress too much over this. I don't want you to like put hours in unless you want to, if you're enjoying that, but it's the class prepares you. So just a little review for what it's worth.